transforming the way we use connected data. And with this latest update, Neo4j is more powerful than ever. You want enhanced performance? Neo4j is unmatched in the market. Neo4j was already 1,000 times faster than relational databases, and with version 5, Neo4j widens the performance lead with new features like K-hop query optimization, graph pattern matching, and granular indexes. You want your data to scale? With 5, Neo4j has unbounded scalability. Autonomous clustering lets you scale out horizontally with less manual overhead and better use of computing resources. And when your data sets lie in multiple databases, Fabric instantly helps you create a composite graph of insights hidden in disparate silos. You want agility? Neo4j 5 has unparalleled operational agility. Neo4j fits your IT strategy, whether it's on-premise, cloud, hybrid, or multi-cloud. And with Neo4j Ops Manager and a continuous release support model, it's easier than ever to manage your database in the cloud. Neo4j 5 helps you achieve unbounded performance, scale, and agility. Find out more at neo4j.com. For over a decade, Neo4j has been helping the world make sense of data. Today, Neo4j, the leader in graph database and analytics technology, is unlocking new possibilities in generative AI. Together, Neo4j and large language models allow you to use a public, pre-trained LLM with your own data, subject to your privacy controls. Reduce hallucination through a powerful combination of deterministic facts and probabilistic conclusions. And enhance explainability and transparency through explicit knowledge representation for getting transparent reasoning and explainable AI. Neo4j's scalable and flexible technology seamlessly integrates with generative AI frameworks like LangChain, Vertex AI, OpenAI, and beyond, democratizing access to the world's information while setting a new standard for AI accuracy, transparency, and explainability. Unlock new possibilities in generative AI today at neo4j.com. There are many types of databases today. The tried and tested relational database, the new and popular document DB, and many others. And all of these have their strengths. But one place they all fall short is in handling complex connections between your data. Sure, any database may be able to return friend of a friend queries of 3 or 4 degrees, but what if you need 20 degrees and need it quickly? That's where Neo4j comes in. Unlike other databases, Neo4j Graph Database doesn't need to compute the relationships between your data at query time. The connections are already there, stored right in the database. Because of this, queries of deeply connected data are orders of magnitude faster. We get used to the limitations of the tools we work with. Neo4j blows those limits wide open, enabling queries never before imagined at speeds never thought possible. That's why Neo4j has become a key technology driving business-critical applications for hundreds of Fortune 500 companies, government agencies, and NGOs. Learn more at neo4j.com. Are you interested in graph data science but don't know where to begin? The Neo4j Sandbox is the best way to get started and learn graph data science basics with interesting preloaded datasets like fraud detection, contact tracing, and Twitter trolls. It's easy to jump right in. follow our guides, and explore visualization with Bloom. There's no download required, and you can get up and running in less than a minute. Try it for free today. Graph databases have been the fastest growing database category for the past decade. The reason for this is simple. Graph databases are highly optimized to understand and work with the complex relationships between your data. Unlike other kinds of databases, a native graph database doesn't need to search for data connections at query time. Those relationships are already there, stored right in the database. Because of this, queries of large, complex, connected data are orders of magnitude faster. A graph database doesn't necessarily need to replace your current database. By adding graph capabilities to your current infrastructure, you can keep the technology you already have, but greatly improve it with the power to uncover rich data connections, reduce time to market, and run faster queries. Taking advantage of the connections that already exist in your data enables you to get ahead of the competition. Every business needs to leverage data relationships and leverage them faster and more efficiently. Graph databases deliver those capabilities. The speed and efficiency advantage of graph databases has driven new, real-time applications in fraud detection, customer 360, machine learning, and knowledge graphs, just to name a few. Because of this, graph databases have become a key technology creating competitive advantage for hundreds of Fortune 500 companies, government agencies, and NGOs. We asked 100 senior tech executives, CIOs, CTOs, and chief data officers what they need to bridge data silos, boost AI/ML projects, and open up new revenue streams. A massive 88% of them said the same thing: knowledge graphs. But why? Leaders know the value of data, keenly aware that it holds the answers to their most pressing business questions. They need insights to improve decision-making and enhance business performance. Enter knowledge graphs. A knowledge graph is a map of everything an organization knows about a given topic. Knowledge graphs help business leaders by functioning as a non-disruptive insight layer on top of their existing data landscape. Knowledge graphs drive intelligence into data to significantly enhance its value without changing any of the existing data infrastructure. Knowledge graphs enhance existing technologies by providing better data management, better predictions, and better innovation. Last but not least, knowledge graphs lend themselves to multiple use cases like fraud detection, digital twin, patient journey, bill of materials management, recommendations, and IT operations across many industries, including financial services, healthcare, life sciences, manufacturing, supply chain, and retail. The C-suite is waking up to the possibility of knowledge graphs. Shouldn't you?
All right. Hello. Good morning, good evening, good afternoon, and thank you for joining to Neo4j Live. Today we covered the potential of LLMs and knowledge graphs through visualization. So I'm very much looking forward to today's episode. I'm happy to have two guests here with me. It's Dienert Vieira and Ben Goosman. Hi, Dienert and Ben. How's it going?
Hi, it's going good. How about you?
Yeah, good. I'm doing well.
Hi.
Hi. I'm very much looking forward to today's episode. I think, I mean, we talked about potential of LLMs and knowledge graphs in all kinds of fashion these couple months, I would say. And we always kind of like covered visualization as part of it, but never really made it the centerpiece. And I'm a big fan of graph visualization. I think it's a great way of exploring data. It's a great way of making data more better to understand what's there, better helps you understand what you can do with it, gives you more insights much quicker than other ways. So I'm a huge fan. So I think that's going to be very interesting today to see, okay, how can you combine this generative AI, the RAG, LLMs kind of world developments that have recently come up with all kinds of AI tools have been released, and now combining this with visualization, with giving it a almost say another spin to the story, to add more detail, to add more insights, and to make a little bit more from the data to add to it, but also to have the power and the possibility to be creative. So I think that's what I kind of like hope for today, but I'll let myself be surprised as well. And I'm very happy to have you two as the experts to talk about this topic, and to give us some insights and your own opinions, and from your experience, what you would say is a good way of how to do that kind of exercise. If you're watching this live, then obviously I encourage you all to ask questions, to give comments, use the chat function as much as possible to make this interactive. We have some time towards the end or sometimes in between. So if a question comes up, or if you just want to comment on something, then please don't be shy. It looks like we lost Dienert now. So hopefully he'll be back in a second. Did you see anything, or did you, Ben? Do you know? Did you heard? Did you hear? Oh, here.
You're due too kind, Alexander. Oh, there he is.
Here he is.
I'm so sorry.
Welcome back.
And the connection was lost.
No problem. Cool. I think we I mean, I kind of like, maybe you two say a few words before we dive in and go on with the content. Maybe, I don't know, Ben, do you want to start and say a few words of who you are, what you do, and maybe what is your connection to graphs?
Yeah, sure. Thanks, Alexander. Hey everyone, I'm Ben Goosman. I'm a senior software engineer at Kineviz. I've been working with them since 2020, and I've been having a really good time learning about graph visualization. You're a little too kind to call us experts, but I like to think we know a thing or two.
I'm sure.
Yeah, I work heavily on Kineviz's GraphXR inside XR, which Dienert will be showing off. And yeah, really excited for this talk.
Cool.
How about me? I have 1 year of Kineviz, and I'm an AI engineer, and I'm working with the team providing new functionalities to GraphXR and developing SiteXR as well as we can. I'll try to get the slides here in just a moment.
I'll post the link to GraphXR in the chat, so if anybody is interested, then check it out. There's also a couple of other links in the video description, so if you are watching this later or you want to know more about it, then there's a couple of other videos that the team has already prepared, and there's a blog as well. So
Okay.
if you want to know more, then check those out in the video description. And here is your desktop. Yes, perfect.
Yes. So we are starting talking about the potential of LLMs and knowledge graphs through visualization. And we have this agenda. We are going to talk about Kineviz SiteXR, the new extension, AI explainability through graph, creating a knowledge map, and the visual exploration using that. To start, we have create a knowledge map for fast navigation and document view in 2 steps. Automatically parse entities and their relationships with open source LLMs and OpenAI. So not only OpenAI, but we have other open models to execute this task, and engage with results through natural language and Q&A and summarization. And we have the poll model. This is the person, object, location, and events. This is the standard entities we have. And this is a result of one extraction of these entities and the relationships between them. So what we want to achieve with all of this, we want explainability AI, explainable AI. We have to understand why some entities were extracted, and why these LLMs indicate those types of relationships between those entities. And we have one special entity, this is observation, that tries to explain a little bit how is done that relationship. And we can frame the context displayed that the AI produced as an outcome of nodes called observation that linked back to the source documents. And we can see for every type of entity how they are related. Before going on, I would like to talk about some articles we have produced, like Anna. Our data scientist has written about the case against Trump, a guide, and she has hosted local LLMs and extracted some entities and used Mistral 7B for that, and OpenAI ChatGPT. And another blog post I have written about exploring the Enron data set. This is a huge data set for 20 years ago, and a bankruptcy, and only 2 CEOs, and how are the exchange of emails between the employees of the company and other people. Also, the whole workflow, the data flow, is from the application we have, the import. We just drag and drop unstructured data like a PDF, text, mail, Word document, slides, whatever unstructured data you have. And we start extracting the entities from this text and highlighting them. And we can use the poll model or create our own entities, like any other entity, and the definition of those entities, like depending on the business model you have. Since we imported a folder, a file, a whole structure of files, we split these documents into chunks, and these chunks are vectorized so we can talk to them. So we chat with them using the LLMs. And then we visualize them in the GraphXR is our platform for visualizing graph charts. And we save all of this in a database like Neo4j, and we present that in GraphXR through SiteXR, this new extension. So this is a view of the chat. We can talk to anything. I will present a bit about the demo, and that's it. I think we can show a little bit how this works in practice.
Sounds good. Yeah, that's very cool. I posted the link to the blog posts, or well, at least to your Medium blog, in the chat as well, so people can find them if they look for these. Here's your screen.
Okay, this is the screen of GraphXR, and this is the default view, and this is the view of SiteXR. I'm going to show a drag and drop here. but I will not see the files, but just I'll show you here as another screen. Can I add another screen? And
You can. Well, not. I don't think you can. I think
let
you need
me
to
show it here.
Yeah.
Like this. I don't have another I am not with a monitor. This is the data source I'm going to upload. It's just markdowns, like murder mystery game. There is the clues, how the murder behaves, and this is all the characters we have. There are suspects, and we have to find out who is the murderer. And let's just drag and drop these files into the sitexr extension and see what do we get. So I'm dragging now the file. I think you cannot see, but I just left some files in this area.
Yeah.
The folder and the file, just drag and drop, and this starter here vectorizing the sources. And you can see here the content, the same content I showed you. And you can see the clues. And it has already vectorized. You can chat with them. But before doing that, I'm going to execute the knowledge extraction. We can run with the default categories, or we can edit and create new categories and the definitions. And I will just run the default poll model here. This is person, organization, location, events from all sources. While we show that, I'm going to click on clues. This is our source visualizer. And we can see the same content of the file I showed before. And we have all of this. And since the knowledge extraction is running now, processing nodes, we can see the result of each entity being detected in the file. So now we have the entities. They detected the murderer, the cat, the pet spider, the dog. Cool. And we can see...
Is this working with any kind of file, or do you need
any kind of file?
Any kind of file? Okay, that's very good.
PDFs, emails, Word documents, text files. And we can see here the observations. There are the relationship between the entities and how they behave. You can visualize this for a start. So here we have GraphXR, the default with the extraction. We can delete the source and also the chunk. I will show the chunk here for example, is chunk could be a lot of pieces of the file. It's gonna be split in many chunks, so we can run on the LLM and extract from each chunk the entities and the relationships from these chunks. And this is a small file, so we have only one chunk here, but we could have many chunks, and I'm going to delete it here. And I can see here how is the relationship. I'm going to organize a little bit for a better visualizing. I'm going to show as a ring layout. And we can show in many ways, like we can, if we click in the murder and present as a tree layout, we have a better visualization for that. And I can also select them and visualize completely these. Okay. So the may have flirting with someone, is not marriage, is only child, enjoys. We can start to investigate our crime or murder mystery and asking like questions about who is murdered, who is married, instead of that. let's chat here and say, who is married? Let's see what we get. This is going through the LLM, and now we get the answer. So the first paragraph, so there is always a warning saying that AI can make mistakes and consider checking information. So our answers are based on references, and we have all the sources here. So who is married can refer to states a murder is not married. So we have here other ways to find our answers, but the murder is not married, indicating they are currently not married in marital status. The right is close. There are contexts that are close related to this answer, and we have some answers here. But this is not a good help for us now. But let's try to search in the index. Like we have here a search in the graph. If I search with this icon, I'm searching only in what I have in the graphs, like marriage. I can search it directly through Neo4j if I click on this database. So I don't have an index now. I'm going to create the index. So let's try to. Oh, now we have the properties, all the categories, and we can select like label from any content, label location, object, organization, person, relationship, source, content, label. We are creating the index so we can search in the database and observation, content. I think that's all we need for now. I'm creating the index and submitting. Okay, now we have the index and we can search in the database. So Mary, the index is still being created. Marriage. Let's see if I forgot something here. I think chunk. I forgot the content.
Sometimes it takes a while, I guess, to create
Yes, I think
the index. So maybe just need a little bit patience.
Let's try for while it's creating. We can try the
chat,
the search here.
What kind of AI did you integrate this with? For the chat?
We use OpenAI and yeah. So now we have here the
maybe
happily
comment in the
married.
chat, maybe a refresh also helps.
Yeah.
Oh yes.
Yeah.
You can try that.
Yeah.
Reboot the computer.
Yeah, maybe later.
So let's see, Mary. Oh, now it works. So we have the two chunks here, happily married. Let's bring again the source of the murder, the clues, visualize, delete again the source, and the chunk, visualizing the tree. Okay, I was going to ask about marriage because I know the murder is not married.
Mhm.
And I know here we have one chunk from the main character and another chunk from the clues. This is what we already have. The chunk from the clues and the chunk from the main character. Is another. If I expand that, if I click on right click button and expand, I can see mention the relationship and expand and see. We have the main character is a person extracted from the source main character. And you see here that plays a role. You can expand all the mentions from the, and we can see here in the chunk that he's happily married. So we can discard the main character as a suspect. I'm
Yeah.
taking notes here of who is suspect and who isn't. It's bad to because I don't have a second screen. But you're going to ask anything?
No. All good. Yeah. But that's
Okay.
helpful. So we already know that we can already rule one out.
So now I'm going to ask in the chat. We have here flirting with someone, marriage, only child, card games, fancy car, drives a fancy car. So we are going to ask in the chat who drives a car. And this is going to use our sources, observations, entities, and answer the question. Like the first paragraph is a summary. And we have here, who drives a car? Based on the given context, we can determine that the writer drives a hybrid car. We can click on it and visualize. Visualize pool. The writer. The writer drives a car. We can also click on the reporter drives an eco-friendly car. The performer drives a fancy eating car, gas eating car, and the antagonist. And also the co-star drives. So we have 1, 2, 3, 4, 5 suspects that drives a car. And this narrows down our investigation to 10, from 10 to 5. And
even
we
says
can
fancy cars, or maybe potentially the eco-friendly car is maybe to be ruled out. Unfortunately.
So I'm going to pull. This is here. If I click in center, it's already here. So pull the reporter, center to the reporter, also pull the performers, center to the performer, and also, so we have here also the co-star. So what else can we ask about? And we have also entity resolution. Like when we extract, and as we have many chunks, entities can be duplicated, And we have a system of entity resolution to merge some entities. Like we have here, if we search for card games, let's go to the entities. What we have, card games here. We can search for similar relationships and see if we have any other that could be merged to that. Let's try to expand here from observation, see if you have other ones. No, we don't. Sometimes the system extracts different entities, and other times we can have that. But this time I only have one.
Okay. Yeah, I mean that's yeah. It's probably because this is auto-generated or AI generated, so sometimes they change it. Yeah. I see.
So we have here other things like the mother doesn't like to taking other people's pictures. Let's ask a question to.
It's a very specific thing.
Yes, we can narrow down very fast if we ask the right question. So who doesn't like to take pictures of the others? Oops. So it takes a little while.
Yeah. Maybe while this loads, maybe we can quickly answer a question that came up a couple of times. If people want to try this themselves, what's the best way to go about to?
Yeah, I can take that question. You can contact us. We can start a conversation about that. We don't have a public trial at the moment.
Okay.
But you can email me at ben@kineviz.com.
Cool.
Yeah, we have here. Oh, now we have some answers here. So based on the given context, the person who doesn't like to take pictures of others is the writer. They hate being in the front of the camera and enjoy taking funny pictures of their cat. In other contexts, we can conclude that the mother does not like. So the writer does not like the picture. Yes. So we can keep the writer. Yes. What else can we talk about? Like jail. Who has been to jail? Let's search the index and see what we get from jail. You have location here, label, and chunk. We can expand from all these chunks. We have the co-star, the antagonist. I'm seeing it here on the name of the URI. So we can bring all of them here and see. From this, we can get the dimensions. We can see the main character, the antagonist, and the co-star, and we can try to map more things like let me see if I have more things in the source of the CoStar. So it has not been detected directly in the first place, but we can see some suggestions of entities that have been detected. We can accept that suggestions of entities. And now we can see from this what have been mentioned. So all of these, that's why I wasn't finding the cards. So like here, I have card games, but I can click on the entities like camera, location, event, occupation, observation, activity, card games. We can click on card games and see there is also another card games that events when we can merge them. If we merge them, we can now expand. If we have the card games here, if I delete this and expand again, now we have a relationship between different chunks, and we can see that the murderer that enjoys playing card games. So the CoStar also.
And he drives an expensive car.
Yes, he's not our
very
number one
suspect
now. And we can go on and expand our investigation and see everything we need. And I have shown most of the features now. And if you have any questions, like we can try to keep on trying to solve the mystery, or we can answer questions, whatever.
We could answer. There's one question from David, more technicalities a little bit. He asks, when does the response enter the Neo4j database? Is the whole visualization on Neo4j? And when you click on pull, you move part of the response to Neo4j. Is that, well, how does it work technically? I guess he wants to know how does what's the connection? How does it work to get the data visualized on the screen?
Yes, we have a functionality that is the expand, and we run Cypher queries underneath that are getting the connections between those categories, and we bring from the database from Neo4j, and we construct the graph accordingly to the properties that these categories have. So we can customize everything here, and I think if this answers the question.
Yeah, so this is basically a web application that runs on top of it. It's connected to I guess OpenAI API and to Neo4j database, and then you query either way.
Yes, exactly.
Yeah, cool.
So we have here like another question that could help us answer better the question. And if we look for tap water, Let's see. So we see that the writer does not drink tap water, and the clues, the murderer does not like to drink tap water. And we can continue our investigation and see if we find the murderer. And we have some suspects, but let's see. So playing cards. Who else play cards? The co-star and the murder mystery. The murderer. Let's see. Jail. Never been to. Never been to is the murderer. And has never been to also is also the co-star. Then the co-star has never been to jail also. Let's see. Clumsiness. Let's ask to the who is clumsy.
It's running again.
Yeah. Okay, who is clumsy? The query who is clumsy refer to the context where it's mentioned that the co-star is banned from a bar, possibly because of their clumsiness.
Okay, that's good.
And mention the characters who is described as clumsy. All of this context says so. The co-star, the writer, a little bit clumsy, the reporter, the costume designer, and the murderer, the clues. So I think that's it. I think most of it leads to the co-star.
Yeah.
We can go on, but I don't be tedious on the investigation. And
Hey, Dienert, have you showed the difference between the related to graph and the observation graph?
Oh yes, that's good.
Like you can toggle that.
Here we have the observation graph and the related to graph, because when we click on that, we'll hide the observations, and only the relation directly to them is gonna be kept on the map. It simplifies a lot the map.
Yeah, so if everything that's not really relevant goes away. Yeah.
Yes, and you can show the relationships, like the name also, related to, and content relationship caption.
Cool.
This simplifies a lot our graph. But for interaction and display, it's sometimes observation helps a bit.
Yeah, absolutely. I can imagine that, if this is now an easier example that we showed, but if you have more complex things where there's many nodes on the screen and many relationships,
Exactly.
Usually it becomes a bit confusing and you don't really understand what's going on anymore, even though it's supposed to help you, but when it's really a lot, then and if you can identify, okay, what's the relationships, who are the important nodes, and then you can show that, and that helps a lot.
Yes, I'm finished here. I think that's all I had. If you have any questions, we are available.
That's cool. Thank you very much. So we had a couple of questions. I think Ben already answered a couple in the chat. I don't know if you, Ben, if you want to add more to it verbally instead of typing. So I think there was a question on what kind of different technology is used for this. So vector databases, graph databases, and obviously LLM connectors. I don't know. Do you want to share a bit more
Yeah,
details?
I can touch on the architecture.
Yeah.
Underlying. We use Neo4j to store all the nodes and edges, the entities, observations, and source documents. We use Quadrant as a vector DB to do semantic search on your text and observations and entities. And Redis is a really handy key value store for app settings and the queuing architecture. And we have a queuing architecture which handles all imported files and sends that through vectorization processes and knowledge mapping processes which orchestrate the calling of the LLMs, of which we support OpenAI, Ollama, Light LLM, which is a proxy server behind that you can put in front of Azure OpenAI, which we use heavily, and OpenAI and other language model providers. Did I miss anything?
No.
That sounds right.
Cool. That's very helpful. Thank you. And another question comes from Rodrigo. Do you think it's possible to apply CiteXR in a scenario where you have lots of PDFs and want to find intersections, semantics among?
Exactly the point of what we are trying to do, because of the merge functionality and try to intercept those entities extracted from many chunks, different chunks, many different documents, and see what we get from this result. And we can relate and ask questions to the same entities.
Yeah, that's cool. Yeah, that's cool. Tony asks, exporting the JSON. So I guess once you've done with the visualization or when we have identified our murder, let's keep in the data set. Can we export the results in some fashion that we can say, okay, here is our murder and this is why, kind of?
Yeah, I can take that. GraphicsR has support for taking screenshots or exporting a CSV. There's a couple options available.
Okay, cool. Yeah. All right. Another question here. Is it possible for a fine-tuned LLM to make it as API so that it can be easily accessible anywhere? Well,
I think I know what that means.
Yeah.
So since we have support for Ollama or a light LLM, if the LLM that you fine-tune has support for the OpenAI spec, then the light LLM proxy server or Ollama can help make your LLM available from anywhere.
Okay. We just answered Siddharth. We just answered that how the results are exported, or do you wanna quickly show that, Dienert? How to export?
Yeah, maybe show the CSV export or taking a screenshot.
Or take a screenshot. Yeah. I mean, so people know. Or maybe we table that for
yeah,
later.
maybe table that one.
Yeah. But yeah, it shouldn't be too difficult to get the results exported in a easy fashion. And if it's a CSV file, then you can.
Let's try to do that.
Yeah, thank you for expanding our murder mystery skill. Yeah, I think that's good. But it's all fun here. But I mean, we can talk a little bit about this. I mean, if you imagine you are a visual, insurance company or a bank or some kind of some other fraudulent endeavor, then I think this could be great to find out. Okay, who is the actual owner of the thing that's supposedly broken, or what's exactly has been stolen, or who it doesn't have to be as drastic as who got murdered, but it can be easy to find these things. Do you have any stories to share here? Anything that was like something that came up when you said, "Wow, okay, now that we see this, and now that we get the connections there, now that we can visualize it, something becomes very clear." I mean, obviously, you don't have to share private things, but if you have some stories, there will be maybe you have something there.
Yeah, it's hard to share any nuggets without going into detail, which we can't share, but definitely along the lines of social network analysis, like getting insight into groups that actively engage in criminal activity, finding the connections between those things is a really great application of the graph. And then being able to use semantic search, similarity search, combined with full text search to locate entities that you're interested in and potential like similar entities is really where the graph shines, because you can connect these things together and then using the visualization quickly see all of them at the same time at a holistic level.
Yeah.
And like you said, fraud is another application we're looking at now. It's like counterfeit products, identifying where they come from and the like.
Yeah, totally. Sounds good. All right, Dienert, let's show how the export
We can export here as a CSV or export a SVG. Like we can come here to the project tab, and from data we can export as a GraphXR and import in another project in GraphXR, save Excel, save modifications to Neo4j also, and categories, relationship settings, all of this is available to download.
Cool. And then if you want to share a view, then
you can save a view here, like found the murder.
Yeah.
And you can share this view publicly, a link.
Cool. Yeah.
And everybody could interact with the graph.
Yeah. Oh, that's handy. That's cool. And then and then you can,
you can update that view and
can we
share
share that link in the video description? Is that something we could do?
Sure. Yes.
Yeah. If you can send it to me later afterwards, something that works. And then I can add it to the video description.
Actually, it's not gonna work because my machine is a private VPN, and I think it's not going to work.
Okay. Well,
this link,
maybe you can. I don't know. Maybe on your website or something. Maybe there's a view that can be shared, or if you can send me a link sometime later.
That's a good idea.
Yes.
You could export it and put it on a public site.
Yeah.
Can you export that right now, Dienert, as a GraphXR file? Just so it's handy.
Yes, sure.
Just want to make sure we get that before GXRF. Yeah.
Cool. I can add that later to the video description, so that people can click on it and explore how it looks like. Great. I think that rounds us up of this session today. Anything you would like to add before we wrap it up completely, Ben Dienert?
I'm really grateful for your invitation, and it was a pleasure talking about our last achievements, and it's been a pleasure for us.
Yeah, thank you, everyone.
Absolutely. Thank you very much. Thank you very much for presenting. Thank you much for spending the time. Thank you for the cool demo. I liked it a lot. It was very cool to find a murder suspect and then identify who it was. Even though I'm a little bit sad that he likes board games, because I also like board games. So I think that gives the whole hobby a little taint now. But never mind. But yeah, it was good, and it was great to see and great to explore this data set, and very easy to combine a couple of lines of text and then drive it in a visualization. So that was super handy. So thank you very much for that. I have one more thing I'd like to mention is the upcoming Neo4j training series. So if you are interested in learning more, if Neo4j and graph database is something that you want to get more skills in, then we have a couple of workshops coming up in March. They go from very intro level style to more RAG application development to geospatial data. So if you're interested in that, have a look at the trainings. There is also a O'Reilly learning session comes up on knowledge graphs and LLMs. They do these in March as well, and you get a 30-day free trial if you use our code, which I also post in chat. So you can check that out as well if you like to try. Oops, now I missed that link here. Here we go. If you like to try, 30-day trial for free and get these learning sessions to do them. And our next live stream is happening next week on the 5th of March. 26th episode of Going Meta is going live, and we will then talk, Jesus Barasas and I, we will talk about knowledge graphs, semantics, and all of that stuff. And in the past, we covered a lot of RAG and knowledge graphs and how to do that. Better Gen AI application development with the two tools together. So I think we probably stay in that vein. So hearing that today, I think we probably look into that a little bit more, and that maybe is a good next step for everybody if you want to learn more. But obviously, check out the Kineviz website, check out the blog, check out the demo that is there available. And like Ben said, if you want to know more about Kineviz and the demo you just seen today, then give them a ping, and you can be subscribed in for a demo and a little trial run, I guess. Cool. Yeah, and with that, thank you all for watching. Thank you for your questions. Thank you for participation. Thank you again, Ben and Dienert, for your demo and for your time. And yeah, see you soon around. Thank you very much.
Right.
Thank you.
Bye, everyone.